Okay, so we're going to start section 5.3 with a review of coterminal angles. So remember, given an angle theta in standard position, a coterminal angle shares the terminal side but has a different angle measure. So if we're in degrees, we're going to add 360 to it. So our first example is adding 360, so we're in degrees mode. So you first have to determine, okay, I can add or subtract. So 490, since it has to be within this interval, 0 to 360, 490 is clearly bigger than that. So what we're going to do is, 490. So we're going to do 490 minus 360. And then this gives us a coterminal angle of 130 degrees. So with 100, it's actually too small. So since it's too small, we're going to take negative 100 and we're going to add 360 to it to get it in between 0 and 360. So we get 260, which is our coterminal angle. And then our last one here is too big, but it's actually 2 times too big. So what we have to do is take 800, subtract 360 twice. And this is going to give us a measure of 80 degrees, which is in between 0 and 360 like we needed. So just note that even if for that last one you did 360 once, you'll notice that it's still greater than 360 degrees. So then that's how you know you have to subtract another 360 from it. So in radians, we need to make sure theta is in between 0 and 2 pi. So negative 5 pi over 6 is too small. So we're going to take negative 5 pi over 6 and we're going to add 2 pi to it. So remember, we need to find a common denominator. So that's going to be 6, which means this 2 turns into 12. Which means we're left with 7 pi over 6 as our coterminal angle. Then 5 pi over 2 is actually too big. So we're going to take 5 pi over 2 and we're going to subtract 2 pi. Again, the common denominator is 2, which turns our numerator into 4. So 5 minus 4 gives us pi over 2 as our coterminal angle. And then this last one, negative 7 pi is too small, but it's actually 4 times too small. So if you take 7 pi and you add 2 pi to it, that gives you negative 5 pi, too small. Add another one, negative 3 pi, too small. Add another, negative pi, too small. Add another, and we actually get pi, which is in between 0 and 2 pi. Okay, so now we're going to talk about reference angles. So given an angle theta in standard position, its reference angle, theta r, is the acute angle formed by the terminal side of theta and the x-axis. Note that the formula changes so that we're either in between 0 and 360 or we're in between 0 and 2 pi, determining if we're dealing with degrees or radians. So if we start with quadrant 2, then we know that we're going to have to either be between 90 degrees or, in radians, pi over 2. And this is between also 180 degrees and pi. So clearly this arrow is in between those two values. So if that's the case, if you're dealing with radians, if you're dealing with degrees, you're going to take 180 and subtract theta, because that's this difference right here. Or you're going to take pi and subtract theta if you're in radians. Okay, so now if we move on to quadrant 3, we are now going to be dealing in between 180 degrees or pi, like before. And we're going to be in between 270 degrees or 3 pi over 2. Again, depending if you're in degree or radian mode. So if this is the case, you're going to actually take theta and subtract 180, giving this difference, or subtract pi, giving that same distance. And then our last one would be in quadrant 4. So we're going to be in between 360 degrees or 2 pi, and like said before, 270 degrees or 3 pi over 2. So if this is the case, you're going to take 360 and then subtract to give you this difference, or take 2 pi and subtract if you're in radians. Now, the reason why we don't deal with quadrant 1 is because they are themselves their own reference angles. So we don't have to subtract anything to it. We already have that acute angle. We don't have to form it or create it. So number 3, we're going to deal in degree mode. So we are going to find the reference angles to these 4 values. So if I start with 315, then looking at the graphs above, we are going to be in quadrant 4. So that's important to know because you need to know our little formula here. So since we're dealing with degrees, we're actually going to take 360 and subtract 315 from it. So our reference angle is 360 minus 315, which gives us the acute angle of 45 degrees. So 150 is in quadrant 2. So this tells us that we're going to take 180 and subtract 150 from it. And we are given the acute angle or reference angle of 30 degrees. Okay, so when given a negative, knowing that, again, it has to be respectively in the positive, so 0 to 360 or 0 to 2 pi, we need to use our knowledge of coterminal angles and find that first. So since it's too small, we're going to do a little bit of work first. 121 plus 360, which gives me a coterminal angle of 239 degrees. So now that we can say is in quadrant 3. So again, we're using our coterminal to determine that. So now we know, since we're in quadrant 3, we are going to take theta, which is our new 239, and then we're going to subtract 180 from it, which gives us 59 degrees. So again, if it's not within 0 and 360 or 0 and 2 pi, you need to find the coterminal angle first. So this next one, 425, we definitely do. So my coterminal angle is going to be 425. I need to subtract 360, and I get 65 degrees. Well, since 65 degrees is in quadrant 1, because it's less than 90, then, like I said before, that's the reference angle. This is already an acute angle. So when it's in quadrant 1, that's it. Okay, so in radians, 5 pi over 4 is in quadrant 3. So this tells us that to find our reference angle, we are going to take that angle and subtract it from pi. And when you do this, again, you could do common denominators. If you wanted to, you get pi over 4. pi over 6 is, again, in quadrant 1, like our last degree example. So the reference angle here is just pi over 6. (17 pi over 3). Well, 17 divided by 3 is more than 2, so we know that we need to find our coterminal angle first. So to do that, what we're going to do is we're going to take 17 pi over 3, and we actually have to subtract 2 pi twice to get in between 0 and 2. So this gives us 5 pi over 3, which is in quadrant 4. So now we know that the reference angle is 2 pi minus our 5 pi over 3, which gives us pi over 3. And last but not least, it's too small and it's out of our interval, so we need to add 2 pi to 7 pi over 3. So we have negative 7 pi over 6. I don't know why I said 3. Negative 7 pi over 6 plus 2 pi. And we only need to do that once, and this gives us 5 pi over 6, which is in quadrant 2. So now we know we are going to take this value, and we're going to take pi first. That's what it says. Pi minus 5 pi over 6. So we're left with pi over 6. Okay, so now what we're going to do is we're going to evaluate trig functions from a point on the terminal ray. So let's just kind of dive into an example and see what this is. So find a value of 6 trig functions, which is our sine, cosine, tangent, cosecant, secant, and cotangent, given that the point negative 5, 5 is on the terminal side of the angle theta in standard position. So all important words: terminal, theta, and standard position. So before we begin, there's a couple rules that we need to follow or note. So when we draw the triangle, the first thing to note is that our hypotenuse is always extended from our origin. Second, the triangle is always going to be connected to the x-axis. Third, the length of the adjacent side equals an x value. And lastly, the length of the opposite side equals a y value, or the y value. So we need to keep these rules in mind. Okay, so the first thing I'm going to do is draw our plane. So we have the point negative 5, 5, which we can say is about, let me just start it from the origin. So we can call this, that point is labeled negative 5, 5. And since we know that, and to get that point, we have to go negative 5 on the x-axis and 5 up on the y. And since this is our theta, and then the reference angle that we just learned about is right here. So I'm going to say theta r. Okay? So from that angle, the opposite is always the y value, which is 5, which is true, and the adjacent is always the x value, which is negative 5, which is true. So the first thing we need to do is find the hypotenuse. Just going to give myself a little bit more room. Okay, so to find the hypotenuse, we are going to use Pythagorean's theorem. So we have, Okay, so we're going to use a little different notation. So let's do it this way. Let's say that we have 5 squared plus negative 5 squared equals r squared. And we're going to call it r because that's our radius. Okay, so knowing that this is a circle, that hypotenuse is the radius. So what we can do is square those, add them, and then take the square root of both sides. And when we do, r is going to equal the square root of 50. And yes, we do need to simplify it. So we could pull 25 out and it becomes a 5 root 2. So that's the value of our hypotenuse. And we're going to keep it in exact form like that. So we have 5 root 2. So now we have everything that we need. The other thing I want to note is that this hypotenuse is always positive. Okay, so make a note of that. The hypotenuse is always positive. Okay, so now we need to find the 6 trig functions. So let's start with sine of theta. So sine of theta equals opposite, which is 5, over the hypotenuse, which is 5 root 2. These 5's canceled, but then we need to multiply by root 2 over root 2 because we need to rationalize the denominator, and we're left with root 2 over 2. So for cosine of theta, it's adjacent. So we have negative 5 over 5 root 2. So after we rationalize, we're going to get negative root 2 over 2. Tangent is opposite over adjacent, which is 5 over negative 5, which is negative 1. Cosecant of theta, we're going to use the original, that 5 over 5 root 2, because we're going to get 5 root 2 over 5. They cancel, so this is just root 2. Secant of theta, again, we're going to use the original, so this is going to give us negative root 2. And then our cotangent of theta is still going to be negative 1 because it has a denominator of 1. Alright, so if the terminal ray of an angle passes through negative 3 comma negative 1, find the value of the 6 trig ratios. Okay, so we're kind of starting from scratch. So the first thing that we need to note is that negative 3, negative 1 is our x, which is less than 0, and our y is less than 0. So this is going to be in quadrant 3. So when drawing our triangle, it's going to look like that in quadrant 3. So this is the point. So we have negative 3, negative 1. We know that this is theta, and then we know that this is our reference angle of theta. Okay, so our first step is to find the hypotenuse, and in doing that, we're going to use the Pythagorean theorem. All right, so again, the square root of negative 3 squared plus negative 1 squared, which gives us the square root of 10, which can't be simplified. So we know our hypotenuse is the square root of 10. Now we have everything we need to do, or know, to do our 6 trig functions. So sine of theta is opposite over hypotenuse, which is negative 1 over root 10. We have to multiply by root 10 over root 10. So our sine of theta is negative root 10 over 10. Cosine of theta is going to be negative 3 over root 10. And after we rationalize the denominator, we're going to be left with negative 3 root 10 over 10. And then tangent of theta is opposite over adjacent, which is negative 1 over negative 3, which is 1/3. All right, so now we're going to do cosecant, which is going to be negative root 10. Secant, which is negative root 10 over 3. And then cotangent, which is 3. And there we go. We have all 6 trig ratios. Okay, so we're pretty much going to do the same approach like we just did the last two, but now we're given slightly different information, so we need to kind of use that information to determine a couple of things. So over here you see our coordinate plane, and you see all students take calculus. So pretty much what this is referring to is that is our signs. So in quadrant 1, all x and y values, so both x and y values are greater than 0. Over here in the second quadrant, sine is just greater than 0, and sine we know is referred to as y. Tangent is both of them, so we have x is less than 0 here, and y is less than 0 here. And then cosine is the next one, where x is greater than 0. Okay, so let's use that. So now, if we know that cotangent of theta is 1/4 and sine of theta is less than 0, so that pretty much says that y is less than 0. That's what that's saying. All right, so we're going to draw a little coordinate graph just to identify the signs. So if y is less than 0, then that means we could be in this quadrant 3 or this one, quadrant 4. So now we need another piece of information. Now we're given cotangent. It's 1/4. So we also know that cotangent of theta therefore has to be greater than 0. And where does that happen? That happens in quadrant 1 because everything's greater than 0, and in quadrant 3 because everything's, I'm sorry, not everything's greater than 0, but for tangent, you have a negative divided by a negative. Now, remember, or up in that top right-hand corner, it says tangent, sine, and cosine, but knowing that cotangent is greater, since all you do is switch, and tangent would then be 4, so since tangent is greater than 0, you can say cotangent is greater than 0, or vice versa. So what does this mean? Where do both of those stars fall in the same quadrant? Right here. So we're going to deal with quadrant 3. Okay, so now what we know is where that terminal angle falls. So if we're going to draw our triangle this time, we know that it's in the 3rd quadrant. Again, this is theta. and this is our reference angle. All right, so since we're using that and we know that cotangent is 1 over 4, then there's a couple ways you can do this. So you can say, well, if cotangent is 1 over 4, then tangent of theta must equal 4 over 1. Well, tangent is opposite over adjacent. So that means opposite is going to be 4 and adjacent is going to be 1. However, we're in the third quadrant. So this is actually -4 and -1. So going back to the two problems we just did before, we were given those values, you know, a terminal point of -1 comma -4. So we knew that already. But because of that all students take calculus, we can determine it's in quadrant 3. So then we know the x and y values are going to be negative in quadrant 3. So now we're right back where we were before. So my hypotenuse just going to abbreviate. My hypotenuse is -4 squared and -1 squared, taking the square root of that, which gives you the square root of 17. And now we're ready. Oh, let me add it to my graph. Now we're ready to do all 6 trig ratios. So cosine, sorry, I usually start with sine. Sine of theta equals opposite over adjacent, or hypotenuse, which is -4 over root 17. So that's actually going to equal -4 root 17 over 17. Cosine theta equals -1 over root 17. So this is going to equal -root 17 over 17. Tangent, we actually already figured out what tangent was. And we don't have to even look at the triangle. We were given that cotangent is 1 over 4, so tangent is 4. Cosecant is going to be -root 17 over 4. Secant is going to be -root 17. And we know already that cotangent is 1 over 4. Okay, another one like this, and I'm actually going to edit this. I believe you will in class as well. Should be -5. Okay, so the first thing we're going to do is cosine is greater than 0. So what that tells me is that x is greater than 0, and sine theta equals a negative number. So we know that y is less than 0. Let's write that in a different color so I can use my chart. Y is less than 0. Okay, so if we did our little star graph for all of our quadrants, x is greater than 0 in the second. No, it's not. Sorry. In the first and the fourth. Sorry about that. And then y is less than 0 in the third and the fourth. So this means the fourth quadrant is where we're going to have our triangle. Okay. So what do we know? We know the sine of theta is opposite over hypotenuse. And since we have sine, we know that this is -5. And our hypotenuse is 13 because that was the value we were given. All right, so now the only difference here is that we're not finding our hypotenuse, we're actually finding our side. So let's just say, x squared plus -5 squared equals 13 squared, which is So therefore x equals the square root of 13 squared minus negative 5 squared. And if you can go straight there, that's fine too. And this equals the square root of 144, which equals 12. So that's our other side. That's our x value. All right, so our trig functions. We already have sine, so we're going to have cosine of theta, which is opposite over adjacent, 12 over 13. And then tangent of theta is opposite over adjacent, so negative 5 over 12. We need to do secant. Which is 13 over 12. And cotangent which is negative 12 over 5. And then we do need to add in our cosecant. And you can look at the triangle, or you know that it's negative 5 over 13 for sine. So cosecant is going to be negative 13 over 5. And there you have it.